This lesson is dividing radical part 2. Here I have an example: 4 divided by 5 square root 3 x to the first power y to the third power. I want to make a note. When you see this symbol, this is square root. When you see a 3, cube root, 4, fourth root, and so on. Also, these numbers right here where I am circling represent a group of how many things. So the first one is square root. Since it is square root, I want a group of 2 things. Cube root, I want a group of 3 things. Fourth root, I want a group of 4 things, and so on. So going back to our example, this is a square root. I want a group of 2 things. Again, this is a square root. I want a group of 2 things. Okay, so by looking at our problems here, I can split this y to the third into a group of 2. One more time, this is y to the third. I can separate this into a group of 2. And this is what I have over here. So the top stays the same, the 5 stay the same, the 3x1 stays the same. However, the y to the third can be separated into group of 2. So here's the group of 2. However, I have an extra 1, the leftover y, because 1 plus 2 gives me 3. One more time, 1 plus 2 gives me 3. And why am I separating this y to the third into 2 different y's? Because this square root wants a group of 2. Again, the square root means group of 2, 3 means a group of 3, 4 means a group of 4. Okay, so that's where the group of 2 y squared came from, because this y to the third can be separated into y1 and another one with y squared because it's a group of 2. Okay, and also because this is a square root and this is a square root, square, they are the same thing, so they get canceled out. So square root and square, they get canceled out, so I just have this y. So this right here where I'm circling become this y, because square root and square, they cancels out. So this right here becomes this y. And the square root 3x1 y1 is on the back. Okay, however, I don't want radical in the bottom, so I am going to rewrite the entire problem here, and then after that only rewrite the radical. One more time, only rewrite the radical where I am circling. Rewrite that for the top and also for the bottom. One more time, I cannot have radical in the bottom, so I want to get rid of this by rewriting only the radicals for the top and for the bottom. Okay, so one more time, this right here where I am circling, I rewrite it exactly as what I have here. Multiply the radical in the bottom exactly as this. Okay, so for top and for the bottom as well too. After that, just multiply across. So I have 4 square root 3xy, and then 5y as is. And then here I have 1, 3, another 3. So that's where I got the 3 squared. 1x, 2x, that's where I have x squared. 1y, and then another y, I have y squared. Okay, and then after that, because this is still in a square root, I can separate individually the 3, the x, the y. That's what I have here, because this is a square root and all of these are under the square root. I can separate it individually. Okay, so square root 3 squared, square root x squared, square root y squared. One more time, all 3 of these are under the square root, so I will separate them individually, and that's what I have here. And as before, square root, square, they can be canceled out, so that's where the 3 came from. Square and square root and square, they cancel out, and I have this x. Square root and square cancels out, so I have this y. Okay, and then after that, clean this up a little bit more. So I have 4 square root 3xy to the top, and then 5 times 3 gives me 15. 1x goes to the front, and then I have 1y, another y, so y squared. Okay, so this is the answer to the problem in the beginning. And how do I know when to stop? When there are no more radical in the bottom. Again, how do I know when to stop? When there are no more radical in the bottom, like right here where I am circling. Okay, so be very careful. One more time. If you see this symbol, that means square root, which also means I want a group of 2 things. If I see a 3, I want a group of 3. If I see a 4, I want a group of 4. Okay, so be very careful of that. Next example, similar situations. So as you can see here, there's a 3 right here, so I want a group of 3. Same thing down here, I want a group of 3. So first thing we need to do is take care of this 16. So I separate this 16 into 8 and 2. And the reason why I chose 8 and 2, because cube root of 8 will become this 2. Okay, cube root of 8 will become this 2 right here. Okay, so 16 is separated into 8 and 2 because 8 times 2 is 16. And then I separate it again, cube root of 8, which is here, cube root of 2, which is here. We know that cube root of 8 is 2 because there are 3 2's. When you multiply 3 2's, it will come out to be 8. So cube root of 8 is technically a group of 3 2's, so that's where the 2 comes from. Okay, and then this cube root square, cube root 2, I leave that alone. And as you can see, the bottom, I haven't done anything to it, so I just bring it along. Next, I want to get rid of this radical in the bottom. So first of all, I rewrite the entire part right here where I'm circling. I rewrite this, okay? But before I can do that, I can simplify this 2 and this 4, and that's what I did here. So 4 is 2 times 2 right here, and then there's a 2 as well, so I can cancel one of the 2. So all I have left is cube root 2 all over 2 cube root 2n. Okay, so what I did was right here, this cube root and this cube root, I leave it alone. What I did was I simplified this 2 and this 4. So I take 2 from here, I take 2 from here, 2 divided by 2, so it's gone, and now I have left is a 1 right here, and then 4 divided by 2 gives me this 2. So I did the work here by simplifying and reducing one of the 2, getting rid of one of the 2. Okay, so this 2 is on top, this 4 is 2 times 2, so get rid of one of the 2, so I have one of them left. Okay, I still have a radical here, so now I'm going to get rid of this radical. So rewrite this whole thing right here, and that's what I have here. I rewrote this whole thing here. Multiply again to get rid of the radicals. I'm going to multiply only the radical, and that's what I have here on the top and also on the bottom. One more time, to get rid of this radical, I will multiply just this radical only to the top and to the bottom. Okay, however, if you look carefully why there is a 2 here and why there's a 2 here, and the reason is because this 3 means I want a group of 3. However, in the beginning I only have 1 2 and 1 n, so I need to add 2 more so that I can get 3. One more time, in the beginning I only have 1 2 and 1 n. So I need 2 more of 2, 2 more of the letter n, so that I can make a group of 3. Okay, so one more time. This number right here means I want a group of 3, but I only have 1 2, 1 n. So the only way to get a group of 3, I need to add 2 more of the number 2, 2 more of the letter n, so that when I add them together, it will give me a group of 3. Okay, so that's where the 2 comes from for the bottom and also for the top as well. One more time. I want to get rid of this radical. So what I did was I rewrote this whole thing right here where I'm circling over here. Multiply just the radical only, and I did for the top and the bottom. However, I need to add 2 of it. I need to add 2 more of the number 2 and 2 more of the letter N so that I can make a group of 3. Why do I want a group of 3? Because of this number right here. Okay, so now I just multiply across. So there's 1, 2, there's 2, 2, and that's where I got the 3 from. 1, 2, 2, 2, that's where I got the 3, because 1 plus 2 gives me 3. This n squared stay as is. Okay, now let's do the bottom. This 2 stay as is, and then I have 1, 2, 2, 2. That's where the 3 came from. 1n plus 2n. So here's 1n, and I have 2n here. So that's where the n to the third came from. Okay, so 1 plus 2 is 3. 1 plus 2 is 3. Okay, next I want to simplify a little bit more. As you can see, this 3 and this 3 are the same, so they cancels out, and that's where this 2 came from. So where did this 2 came from? From the top here. So 3 and 3 cancels out, so bring down this 2 right here where I'm circling to here. The 3n squared, the cube root n squared, leave it alone. This 2, I bring it down. Okay, so this 2 right here, I bring it down here. 3 and 3, they cancels out because they are the same, so bring down this 2 to here. This 3 and this 3 are the same, so it cancels out. I bring down the n. Okay, and then finally simplify a little bit more. I can get rid of this 2 and this 2. I can get rid of one of the 2, so get rid of one of that. So I still have 2 and then the letter n. Okay, so the final answer is cube root n squared all over 2n. Again, this 2 and this 2, I just got rid of it. I still have this 2n, so I wrote it down here. Okay, so this is the answer to this problem up here. So this problem is a group of 3. What I did earlier was a group of 2. Okay, so this problem is a group of 2, and over here is a group of 3. If this was 4, you do the same process. Okay, so 3 means I want a group of 3. If this was 4, I will get a group of 4. Okay, so be very careful when to use group of 2, when to use group of 3. Okay,